Is review video part 2, and I'm going to keep going where we left off. So we were on tangent equals negative root 3. Now you might remember tangent is the comparison of y over x. So we know we're going to need a y value over an x value, but the question is which angle are we looking at? Here's what I mean. If we look at all the points around the unit circle, I am thinking we are not going to use anything 45 or pi over 4 based. Because if you took root 2 over 2 divided by root 2 over 2, that ratio is 1. Because the answer has a root 3, I'm thinking we're going to have either be 60 degrees or 30 degrees based. But we don't know which one yet. So what we want to do is take this y value divided by this x value, and this y value divided by this x value to see which one gets us root 3. So let me try both. Let's first take 1/2 and divide it by the square root of 3 over 2, which is relating to this angle over here. So that would really be 1/2 times the reciprocal of 2 over root 3. So that would be 1 over root 3, which would be root 3 over 3, which is not quite what we're looking for. So let's switch the order. If we did root 3 over 2 as the y value, divided by 1/2, that is root 3 over 2 times 2 over 1. And if the 2's cross out, that does get me root 3. So that makes my eye go to this angle here, a 60 base angle, because if we take root 3 over 2 and divide it by 1/2, like we want to do for the tangent, y over x, we're going to get root 3. We're not asking where the tangent is positive root 3, though. We're asking where it is negative root 3. And you might recall from previous videos that the tangent is positive in quadrants 1 and 3, so it's negative in quadrants 2 and 4. So that means to me that if I'm looking at this picture, where would the tangent be negative root 3? So first we want to make sure to choose an angle that is 60 based. So we're taking root 3 over 2 divided by 1/2 here, taking root 3 over 2 divided by 1/2 here. Oops, I think that's the wrong one. We would want to choose, choose this one, because we want to take root 3 over 2 divided by 1/2, root 3 over 2 divided by 1/2. Because these are the two locations where tangent is negative, my two angles are either going to be right here or right here. So my answers squeezed down here in radians would be either 2 pi over 3 or 5 pi over 3. And my answer in degrees would either be 120 degrees or 300 degrees. That I would say is the sneakiest one on the page. The next one I like a lot more. Where is the sine, or the y value, 0? Well, again, let me erase what I previously have here. It gets in the way. So if we have a fresh new unit circle, and we come back to this problem, where is the y value 0? Well, the y value is 0 here, as well as right here. And remember, we're restricted to one time around the circle. So my two angles in radians would either be at 0 or pi. And my two angles in degrees would either be 0 degrees or 180 degrees. Last but not least, the cotangent of theta equals -1. Remember that the cotangent and tangent are reciprocals. So if cotangent of theta equals -1, tangent of theta would be the reciprocal of -1 over 1, which is still -1 over 1. So we're asking ourselves, where is the tangent y over x equal to -1? Well, this time, the only angle that has a ratio of 1 would be a 45 or pi over 4. Because if we take a look at these two numbers, if we take square root of 2 over 2 divided by square root of 2 over 2, that ratio is 1. But again, we want the tangent to be negative. Tangent is negative in the second and the fourth quadrant. So the 45-degree based angles in those quadrants are so in radians, it would be 3 pi over 4 or 7 pi over 4. And in degrees, it would be 135 degrees or 315 degrees. So definitely knowing this unit circle and how to use it will help you with all of these problems on this page. Reference angles and coterminal angles. These I think I'm going to go straight through because I think it's good reminders. If we want to find the coterminal angles for 17 pi over 5, you might remember that coterminal is spinning around the circle infinite times. So if you spin around the circle once, that you're adding or subtracting 2 pi from your current angle. So if we take 17 pi over 5 and we subtract 2 pi, the reason I subtracted first is because the number is larger. 2 pi in this situation, if this is a common denominator of 1, we would need to multiply this by 5 over 5, which is really 10 pi over 5. So if we took 17 pi over 5 minus 10 pi over 5, we would get 7 pi over 5. That would be a coterminal angle, and we want to find one positive and one negative. So one of my answers could be 7 pi over 5. If I wanted to find a negative coterminal, I could start where we left off. 7 pi over 5 minus 2 pi, which is 10 pi over 5. So that would be negative 3 pi over 5. So that could be my next coterminal angle. If any of you were asking, could I have taken 17 pi over 5 and added 2 pi at the beginning? Yes, you could have. And I believe if you did, you could have gotten the answer also of 27 pi over 5 if you wanted to try that instead. Now, in terms of reference angle, a couple reminders. A reference angle is always acute. It is positive and it is related to the x-axis, or it is coming from the x-axis. And so in order to see a reference angle, again, what we generally want to do is draw a picture. So because this angle is in fifths, you might remember I was talking about a common denominator in previous videos. So this is really 0 pi over 5. This is represented by pi, which is 5 pi over 5. And we want to get to 17. So again, we are going from 0 to 5. So this is really 2.5 pi over 5. And this is 7.5 pi over 5. So notice we're trying to get to 17, so we're not there yet. So if I grab a different color here, if I add another 2.5, we'd be at 10 pi over 5. If we go from 10 over here, we'd be at 15 pi over 5, because we're adding another 5 pi to get here. So because, and then here, let's see, another 2.5 would be at 17.5 pi over 5. So if I want to graph 17 pi over 5, I think that's going to be pretty close in my third quadrant. So what I really did was I started here, I went all the way around the circle, and then I landed back in my third quadrant. And so what we want to do is to find the reference angle. So if this is where my angle is, the reference angle is the angle here, the acute angle related to the x-axis. And the way that I think is best to find that is, you know it's related to the x-axis, so you know it's related to this, which we most recently called 15 pi over 5. So how far does it take to get from 15 pi over 5 to where we landed at 17 pi over 5? Well, you go another 2 pi over 5. So that would be your positive acute reference angle. The next example, we start with negative 23 pi over 7. So if we want to find coterminal angles, I would suggest adding 2 pi because the answer is negative and we know we want one positive answer. So if we start with negative 23 pi over 7 and add 2 pi, the common denominator is 7, so we need to multiply this one by 7 over 7. So we get negative 23 pi over 7 plus 14 pi over 7, and that would get me negative 9 pi over 7. So that could be my negative answer. But if I want to keep going and find a positive one, I could start where we landed, add another 2 pi, which is 14 pi over 7, and that would be 5 pi over 7. If we are talking about the reference angle, again, what I will do is draw a picture of what's going on. So this time, our denominator is sevenths, and we are a negative angle, so we're going clockwise instead. So this is really 0 pi over 7. This would be negative 7 pi over 7. And just thinking big picture, to get from here to here, we're going 7, and then here to here, we're going 7. So if I chose a different color, this next time would be negative 14 pi over 7. And then if we landed here again, if we added negative 7 to negative 14, that would be negative 21 pi over 7. We want to find negative 23 pi over 7. So your angle is going to land in the third quadrant. So what you really did is you started here at the initial side, went all the way around once, landed right here. But again, our goal is to find the reference angle. And so if this is where our angle landed, the reference angle would be the acute angle made with the x-axis. So let's think about what we did last time. This angle is related to this x-axis, which is called pi, or negative 7 pi over 7, or more recently, negative 21 pi over 7. How many steps does it take to get from negative 21 pi over 7 to where we landed at negative 23 pi over 7? Well, it technically takes negative 2 pi over 7 steps, but because the reference angle is always positive, I would have the answer of 2 pi over 7. These next two examples, because I went through two in detail, I'm giving you one that's in degrees and one that is also dealing with the common denominator. At this point, please pause your video, and I'd like you to try these two on your own, and I will come back and show you my work for these two. Guys, so time for some more coterminal angles and reference angles. For the degree question, what I did was I took 478 degrees minus 360 get 118 for a positive coterminal angle. Then I took 118 minus 368 again to get negative 242 degrees for my second one. You could have had different answers than me. Feel free to check with myself or your teacher tomorrow if you did. In terms of a reference angle, what I did was I first drew a picture down here. 478 degrees is going all the way around one time, landing at 360. And then once you land at 360, you are really going 118 degrees beyond 360. It is not a coincidence that that's a coterminal angle. So in terms of the reference angle, I know the reference angle is related to the x-axis. So again, I looked here and I said, if this is 180 degrees, I used up 118, so the remaining portion must be 62 degrees, which is where I got my answer. This example here, again, you needed common denominators, but first, in terms of coterminal angles, what I did first is I took 21 pi over 16 and say I subtracted 2 pi, which is the same as 32 pi over 16 with a common denominator. This reduced to negative 11 pi over 16 for a negative coterminal angle. I also took 21 pi over 16 plus 2 pi, or 32 pi over 16, and I got an answer of 53 pi over 16. Reference angle time. I drew my picture. I got a common denominator of 16, 0 pi over 16. So over here it would be 16 pi over 16. So halfway, or 8 units up, would be 8 pi over 16, and this would be 24 pi over 16. So 21 pi over 16 had to be between 16 and 24, so I put that angle in the third quadrant. And then I said, okay, we know this little tiny reference angle relates to the x-axis, so we're going from 16 pi over 16 to 21 pi over 16. That is 5 more units, so that's where I got 5 pi over 16 as my reference angle from here to here. So guys, again, because I'm trying to be very, very thorough on this quiz review, I again need to use a third video to explain the last couple problems. My apologies and thank you for your patience going from video to video, but I hope that these review problems are helping you review for the quiz. Thanks, and please join me on video number 3.